Okay, we are working on question 3 on our worksheet for section 2.1. We're practicing some true falses. So we've got 3 sets up here that we're going to be using, A, B, and C for this question. They have various elements in them, and we're going to ask some questions. We'll start with part A over here. It's asking, now most of this question is remembering our symbols. So this one is B is an element of A. And if we look at the list of elements of A, we see that B is indeed one of them. So this would be a true statement. As we look at our next one, remember this symbol right here means B is a subset of A. This one we have to think about a little bit, where remember the definition of a subset is you need to be yourself a set, and you would need all of your elements contained in the other set. Now, B is not a set. B is just a letter, so it can't be a subset. This would be false. Now, these next two are asking somewhat similar questions, but notice, rather than just looking at B, we're now looking at the subset, or sorry, the set containing B, right? Those curly braces indicate the fact that this is a set and anything listed inside is an element. So the set containing B is that an element of A. Sometimes this one gets a little tricky to think about because B is indeed an element of A. But notice that amongst the list of the elements of A, there is no set containing B. What that would have to look like is we would have to have something where A has some stuff written, and at some point in the comma-separated list, there would have to be a set containing B. There'd have to be a B in curly braces, which is not the case for the set A. So this set containing B is not an element of A. This is a false statement. When we look at the next portion of this, notice this next one asks, is the set containing B a subset of A? So now what we're doing is we're comparing elements of the sets. So the set containing B, well, as we're saying, it contains B. So then the question is B also an element of A? And yes, it is. So this would be a true statement. They are indeed subsets of one another. Okay, part E. Again, now we're looking at that is an element symbol. We want to know, is bag, is the word B-A-G, an element of C? Now, individually, the letter B, the letter A, and the letter G are elements of C. But again, notice that this is not something where we have in the list B, A, G all together as being an element. There's a difference between individual letters versus a collection of letters being an element. So over here, bag, the collection of letters, does not show up in the list for C. So this would be a false statement. The next one down, at part F, we're asking, is A a subset of C? So remember to check this. We check, are the elements in A elements of C? Now, if we start to check, A and B are okay, but notice something like the element C is in A, but it's not over here in C. So therefore, that fails the definition of being a subset. This would be false. Now, when we look at that the other direction, when we look at, is C a subset of A? Now we're looking at them in this order. Is A an element of A? Yes. Is B? Yes. And is G? Yes. So every element in C also shows up in A. So this would be a true statement. All of the elements of C are also elements of A. Now another question then. Remember the slight difference between this symbol and this symbol. Notice this one has that bar underneath and this one does not. When we're taking a look at that, remember the one with the bar underneath, we kind of think it means is a subset of, and the other one means is a proper subset of. The one with the bar means it's okay to be equal. The one without the bar means I do not want to consider equality. It's sort of like less than or equal versus less than in terms of those symbols. So we're looking at, well, is C a proper subset of A? So yes, we already checked that C is a subset of A, and further we can see that C does not equal A. So this would be a true statement. C is a proper subset of A. All right, moving up to the top, we've got a question of, is B a proper subset of A? Now remember, to be a proper subset, you first have to be a subset. So let's check our elements. Well, is A an A? Yes. Is D? Yes. Is G? Yes. But is H? No, H does not show up in A. So therefore, we do not have that B has all of its elements being elements of A. So this would be false. So in order to be a proper subset, you first have to be a subset. So it fails the being a subset part. Now this next one's that interesting case where we can almost look at these two together. The first one asks, is A proper subset of A? The second one asks, is A subset of A? Well, let's start with part K first. Is A subset of A? Well, you check every element and ask, are all of the elements here? Elements here? Well, yes, every element of A is an element of A. Therefore, this would be true. You are a subset of yourself. Now, when we go to J, we are asking further, is it a proper subset? Well, remember, being a proper subset means you're a subset, but you're not equal. Now, obviously, by definition, A is equal to A, so this one must be false. So A is a subset of A, but not a proper subset of A. Okay, part L. Now we have to remember this symbol now. Remember, this was the empty set. Is the empty set an element of A? Now remember, to be an element, you have to actually be listed in the list, somewhere in there separated by commas, which we see in that list. This symbol for the empty set does not show up, so this is false. Now the next part, part M, we're asking, is the empty set a subset of A? Well, if we remember our fact that we learned, the empty set is a subset of every set, so this is true. Part N is an interesting question. Notice here, let's really pay attention to what this set is. Notice this is the set containing the word bag. Notice there are no commas. There's only one element in this set. It is the collection of letters BAG. And if I look at the list of elements of A, the collection of letters BAG, the word bag does not show up in the list. So therefore, I do not have that the elements of this set are elements of this set. So this would be false. Now, if we compare that to the next part, we can see this one does have those commas in there. So we're really looking at, is the letter B, so is the element B in A, is the element A in A, and is G in A, and yes for all three of those. So this is true. The set containing BAG is a subset of A. And our last one here we're asking, is A a proper subset of the set containing A, B, C, D, E, F, G, bird, goat, and dog? So we've thrown a bunch of extra things in there. Notice they aren't letters, but it really doesn't matter. I can put whatever I want in a set. We also should just get rid of this extra comma that shouldn't be there. That's just a typo. So now we're, remember, looking at the order. Are all of the elements of this set elements in this set? So A contains A, B, C, D, E, F, G, and yes, A, B, C, D, oops, E, F, and G. So really the typo is that there should be a D in here. I'll have that fixed on your worksheet that you get, but so on yours it will have a D on there. So indeed, we do have that all of the elements. We've got A, B, C, D, E, F, and G are in there. And then further, for a proper subset, we check, are they equal? And no, they're not equal because this has these extra elements to it. So this would be a true statement, assuming that I fixed that typo right there. So that typo will get fixed so that we do have between C and D, or C and E, we have the letter D in that other set written down. Definitely a lot of parts to this question, so definitely go back, rewind, and rewatch any parts that you might need, and let me know what questions you may have.